Good morning to all of you. Today our subject is engineering mechanics. Engineering mechanics. Last class I have discussed what is work, power, energy, and law of conservation of energy, also work energy principle. Today we will discuss what is momentum, what is impulse, and what is impulse momentum equation. Clear? Now, first we will discuss momentum. Clear? The movement of a body, the momentum of a moving body is defined as the amount of motion, the amount of motion produced by the body, produced by the body. Yeah. What amount of motion produced by the body is called momentum. So every body has two types of motion: motion of translation, motion of rotation. So in case of linear motion, the momentum is equal to product of mass and its linear velocity. In case of rotation, the momentum is equal to the product of moment of inertia and the angular velocity of the body. Clear? Now, every body has two types of motion. A body has two types of motion. Two types of motion. Clear? Number one, motion of translation. That is linear motion. That is linear motion. Number two, motion of rotation. That is angular motion. Clear? So everybody has two types of motion. Either it can move in a straight line, that is rectilinear motion of the body. Another motion is it can move in a circular path, rotational motion. So when body has motion of translation, when a body has motion of translation, the momentum is equal to translation means linear motion, means linear motion the momentum is equal to the momentum is equal to the product of mass of the body and its linear velocity. Linear velocity. That is moment of P is equal to m into E, where m is equal to mass of the body. Mass of the body. V is equal to its linear velocity. Linear velocity. Right? Now, in case of rotational motion, when a body has a motion of rotation, when a body has a motion of rotation, the momentum is equal to the product of moment of inertia and its angular velocity. Clear? That is lambda is equal to I into omega. Where lambda is equal to angular momentum. I is equal to moment of inertia and omega is equal to angular velocity. Clear? That P is called linear momentum, lambda is called angular momentum. Now, note 1. A force produces change of linear momentum. Right? The rate of change of linear momentum, the rate of change of linear momentum is equal to impressor force. Impressor force. Clear? A force produces change of linear momentum. Hence, the rate of change of linear momentum is equal to that impressor force. Similarly, note 2. A torque produces change in angular momentum. Angular momentum. Clear? The rate of change angular momentum, the rate of change of angular momentum is equal to torque. Equal to torque. Which proportional torque is proportional to torque. Clear? Now, impulse. Impulse. I. Whenever a large force is applied on a body for a very short interval time, then the product of the force and its time of impact is known as impulse. Right? So what is impulse? Impulse is defined as, or when large force is applied on a body for a short interval time, for a short interval of time, then the product of then the product of force and its time of impact is known as impulse. Known as impulse. Right? So whenever a force acts in a body for a very small interval of time, the force and the time, when multiplied each other, that produces impact. So impact is defined as, so impulse, that is called impulse. Hence, impulse is defined as the product of force applied on the body, applied on the body, and its time, and its time. That is, impact I is equal to F into T. Right? What is unit? Newton second. Newton second. Now, suppose a body of mass m moving in a straight line, moving in a straight line, straight line, straight line. Let m is equal to mass of the body. What is m is equal to? Mass of the body. U is equal to initial velocity. This is body motion from A to B, A to B at A velocity U, at B velocity V, time taken from A to B, t seconds, A is uniform acceleration of the body. Clear? So, what V is equal to? Final velocity. T is equal to time taken. Time taken. A uniform acceleration. Uniform acceleration. Uniform acceleration. Now, initial momentum. Initial momentum is equal to m into u. What is the momentum? Product of mass and its velocity. So mass remains constant, its initial velocity u. What is the initial momentum? M into u. Similarly, final momentum, mass into final velocity. Initial velocity u. What is final velocity? V. Change of momentum. mv minus mu. Final momentum minus initial momentum. Right? So m into v minus u. Clear? Now, the rate of change of momentum mb m into b minus u by t. What is b minus u by t today? What is a is equal to? B minus u by t. So what is the rate of change in momentum is equal to? M into a. What is m into a is equal to? Force F. What is m into a is equal to? Force F. Now come to definition. Come to definition. Impulse I is equal to force into time. Product of the force and its time of action. What the F is equal to m into a into t. M is what is a? V means u by t. T. Right? So what is impulse I is equal to F into t is equal to m into v means u. What is m into v means u is equal to? Change of momentum. Change of momentum. Hence, impulse I is equal to product of force and time equal to change of velocity, change of momentum. That is final momentum minus initial momentum. This is known as impulse momentum equation. This equation is known as impulse momentum equation. Impulse momentum equation. Right? We have now three equations. Number one, D'Alembert principle. Number two, work energy principle. Number three, impulse momentum equation. We already done some problems for D'Alembert principle. Also, we have done some problems for work energy principle. Today, I will do some problems for this impulse momentum equation. Then I will do problems mixing of three. Clear? Very important topic. So, you see very carefully. Any problem you can solve in of the three methods. If acceleration is given, then you can, or acceleration is required to find out, we apply D'Alembert principle. If velocity given, you can apply work energy principle. If time given, you can apply impulse momentum equation. So, our what is question, what is given, what is asking in the question. So, accordingly, we can solve the problem. Now, I'll do some problems for impulse momentum equation. Clear? This is problem number. This is question number 114. The question is a block of weight 130 Newton is on an inclined plane whose slope is 5 vertical to 12 horizontal. The initial velocity of the block, the initial velocity down the inclined plane is 2.4 meter per second. What is its velocity 5 seconds later? Means after 5 seconds, what is its velocity? Take mu is equal to 0.3 for all contact surface. Suppose this inclined plane the block is here, weight angle theta. Suppose this is This is 130 Newton. The slope 5 vertical to 12 horizontal. 5, 12, this angle theta. This is 13. 5 square plus 12 square is 13 square. So this is block 130 Newton. U is equal to 2.4 meter per second. Block is V. So its velocity V after 5 seconds. T is equal to 5 seconds. Right? This is the question. Again I will read in the question. A block of weight 130 Newton, this 130 Newton is on an inclined plane whose slope is 5 vertical to 12 horizontal. This is point A. Initially the block is at A. What is its velocity? Its initial velocity is 2.4 meter per second at A. U. What is its velocity after 5 seconds? What is V? Clear? This is A point, this is B point. So at B, what is its velocity? B. Take mu is equal to 0.3. Coefficient of friction. Mu means coefficient of friction. Time 5 seconds. Mu is equal to 0.3. Now, this is question. Again, I will draw the figure large size. This is block. Weight W. What is weight is equal to? 130 Newton. So, this angle theta 5, 12, 13. What is sin theta is equal to? 5 by 13. What is cos theta is equal to? 12 by 13. Right? So, this x-axis, this y-axis, this is 9 degree. Clear? X-axis, y-axis, this angle is 9 degree. Now, this angle theta, clear? So, what is this angle? 90. This angle, 90 minus theta. So, what is this? Theta. Clear though? Now, what is this force? This is W cos theta. This is W sin theta. Right? W cos theta, W sin theta. Again, block move from A to B. Block moves from A to B. Right? So, at B, its velocity is V. A, U. What U is equal to? 2.4 meter per second. This is friction F. What is F is equal to? Mu Rn. F is mu Rn. What is Rn? This is Rn. What is Rn is equal to? Double cos theta. So time taken from A to B is equal to T. What T is equal to? 5 seconds. Mu is equal to 0.3. T is equal to 5 seconds. Clear? Now apply impulse momentum equation. Impulse momentum equation. Acha. Now what is Rn is equal to? Double cos theta. What is Rn is equal to? W cos theta. 12 means 130 into what is cos theta? 12 by 13. 10. What is Rn is equal to? 120 Newton. Right? 120 Newton. Now this force mu Rn double sin theta. What is the resultant force? Double theta sin theta minus mu Rn. According to impulse momentum equation, impulse momentum equation, W sin theta minus F is equal to ma into b minus u. Right? Where m is double ag. Where what is m is equal to? Double ag. What is b is equal to? Final velocity. Clear? B is equal to final velocity. M is equal to double ht, double ag. So what is the impulse momentum equation? F into t is equal to m into v minus u. Resultant force F t. Clear? This is resultant force F into t joule m into v minus u. Now put all the values. Put all the values. Now double sin theta minus F mu Rm into t is equal to m into b minus u. So W, what is W? 130 into sin theta. What is sin theta? 12 by p by h. 5 by 13 minus mu 0.3 into what is Rn? 130 t 5. Clear? M into v minus u. What is m? Double ag 130 by 10 into v minus u 2.4. Right? Now find what is the value of b. This is 0 0 cancel. 10. Right? Now making calculator, using calculator solve the problem. Now b is equal to, you can find out b is equal to 7.68 meter per second. Right? B is equal to 7.68 meter per second. This can also be solved using D'Albert's principle or using work energy principle. But we should find out, in case of D'Albert's principle, we will find out acceleration A. Clear? In case of work energy principle, we will find out distances. So if distance is given, we will apply work energy principle. R into S is equal to half into m into v square minus u square. This is work energy principle. So D'Albert's principle, accordingly motion of the body, acceleration is acting, opposite to acceleration, m is acting. Clear? This impulse mode equation, this answer is find out by using time t. Clear? Next question 1 on 5. This is question number 1 and 5. Very important question. 6-mark question for semester examination. The question is, a 1500 Newton block is in contact with a level plane. The coefficient of friction with the contact surface is 0.1. If the block is acted upon by a horizontal force of 300 Newton, what time elapses before the block reaches a velocity of 60 meters per second, starting from rest? Again, if 300 Newton force is then removed, how much longer it will continue to move, and how much distance it can move? Clear? First draw the figure, then I will solve the problem. This is block is at A, then B, then C. Clear? At A, it's the block weighs 1500 Newton, W. Newton. Normal action Rn. The block is acted upon a force F is equal to E is equal to 300 Newton. Clear? The block is acted upon by force E is equal to 300 Newton. And the block starting from rest, U is 0. Rest means U is equal to 0. Right? At B, velocity v is equal to 60 meters per second. So what time taken t? What time taken for the block from move from A to B? Then after reaching at point B, the 300 Newton force is removed, and at this point B, its velocity is 60 meters per second. So when this 300 Newton force is removed, the come to stop, the block comes to stop. Suppose at point C point. What if V dash is equal to 0? This U dash. Or is it V1 U1? This U1 is equal to V1. Clear? This is S1. So time taken is equal to V1. This is S2. This is S. Now, the block is moving forward, so friction acting backward, F. What is F is equal to? URN. F is equal to mu to R. Now, the question is a block weighting 1500 Newton W and mu is equal to 0.1. Clear? W is equal to 1500 Newton, mu is equal to 0.1. The block is acted upon by force of 300 Newton. E is equal to 300 Newton. What time it will take to reach a velocity of 60 meter per second starting from rest? What is U is equal to? 0. At a, but V is equal to 60 meter per second at a B. What time taken? T is equal to time taken. Next, if this 300 force is removed, how much longer it will take? Means time, again time. How much longer it will continue to move? That means what is time taken from B to C? So from B to C, time T1, A to B, time T. Clear? Now first from A to B. From A to B, from A to B, what is M is equal to? WG. What is M is equal to? WG. W means 1500 by G means 10. M is 150 kg. What is Rn is equal to? W. Clear? Now, according to impulse momentum equation, clear? 300 minus mu Rn into T is equal to M into B minus U. Clear? So 300 minus mu means 0.1. What is Rn? What is Rn? 1500 into T is equal to M into, what is M? 150 into B minus U, 60 minus 0. T, what is T? You will find out T. Clear? 0.1, 0 cancel. So 300 minus 150. 150 into T is equal to 150 into 16. So 150 cancel out. What T is equal to? 16 seconds. This is time taken from A to B. T is your time taken from A to B. Now, from B to C. From B to C also, this is F. F. What is F is equal to? Mu Rn. This Rn, W. double 1500 Newton. Clear? F is mu Rn. What is F is equal to? Mu Rn. Again draw the figure from B to C. From B to C, B to C, Rn is equal to double 1500 Newton. F is equal to mu Rn. So 0.1 into what is F is equal to 150 Newton. Clear? U1. U1 is equal to V 60 meter per second. Initial velocity. Clear? V1 is equal to 0. Final velocity. T1 time taken. Clear? T1 time taken. Now, according to impulse momentum equation, this F0, P0, here P is equal to 0. Again draw the figure here. This is A, this is point B, S1, U1, 60 meter per second, V1 is 0. Normal action, Rn1, friction, F1, P is equal to 0. P is equal to 0. Clear? Now, what double 1? 1500 Newton. This is mu Rn1, 0.1. Clear? Now, Rn1 is equal to 1500 Newton. This is equal to this. P0, what is F1 is equal to mu Rn1, 0.1 into 1500, 150 Newton. Now, according to impulse momentum equation, this P0, so 0 minus F1 into T1, M into V1 minus U1. This is answer. Clear? This is answer for this question. So 0 minus what is F1? So what is F1? 150 into P1 is equal to M double G 1500 by 10 into B1 0 minus P1 16. Clear? Now minus 150 T1 is equal to 150 into minus 16. Minus 1 se cancel out. 151 cancel out. What T1 is equal to 16 seconds. Right? This is time taken to reach from B to C before coming to stop. Means B1 is equal to 0. Clear? This is our question number 115. Next. One 6. Now, this is question number 116. The question is, a 20 kilonewton automobile is moving at a speed of 70 km per hour. Clear? When the brakes are fully applied, all the four wheels to skid, to slip. Determine the time required to stop the automobile. Number 1, on a concrete road for which mu is equal to 0.75. Number 2, on ice for which mu is equal to 0.05. In both cases, we will find out what time required to stop the automobile. Clear? First draw the figure. This is automobile vehicle. Clear? This point A, by W, A, this point B. The automobile 20 kilonewton automobile, W 20 kilonewton. Clear? Is moving at a speed of 72 km per hour. U 72 km per hour. B0. Normal action Rn. Normal action Rn. Friction F. What is F is equal to? Mu Rn. This is mu. So time taken from A to B, T seconds. T seconds. Right? Now write the given data. W is equal to 20 kilonewton. So 20 into 10 to 3 Newton. U is equal to 72 km per hour. 72 into 1000 by 3600 meter per second. Right? So 2 zeros cancel out. 20. So U is equal to 20 meter per second. The vehicle come to stop. V equal 0. Vehicle come to stop, that means V is equal to 0. Now, what is Rn? W. 20 kilonewton, 20 10 to minus 3 plus 3 Newton. F mu Rn. So mu into W or mu into 20 into 3. Clear? So no force acting towards right side, only mu are acting towards the left side, frictional force. So after applying brakes, initially the vehicle is at 72 km per hour. After applying brakes, the vehicle comes to stop. B0. Clear? Initially, the vehicle is at 72 km per hour. After applying brakes, the vehicle comes to stop. That means B is equal to 0. So what time taken to reach from A to B? Clear? So mu, different mu for concrete and for ice. Different value, different mu. Now, according to impulse moment equation, according to impulse moment equation, minus F into T is equal to M into B minus U. What is T? T is equal to time taken from A to B. Clear? So minus what is F? Mu Rn, mu W, minus mu W into T is equal to M double G into B minus U. 0 minus or U 20. So W cancel out. W cancel out. Now minus mu into T is equal to minus 20 by G. G means 10. Minus cancel out. So mu into T is equal to 2. T is equal to 2I mu. T is equal to 2I mu. This answer for T. Now put value of mu for different surface. For different surface. Now price mu is equal to, for concrete or mu is 0.75. Number 1, for concrete mu is 0.75. So T is equal to 2 by 0.75. Clear? So T is equal to 2 by 0.75. The value may be 2.66 second. 2.66 second. Next, price. For ice, number 2. What is mu is equal to? 0.5, 0.05, 0.05. So T is equal to 2 by 0.05. So 2 by 500. So 200 by 5. 40 second. Right? This answer for T. Clear? This is for concrete. This is for ice. Now, this is our question problem for impulse moment equation. Next class I will do some common problems. Mixing of Dale's principle, work and principle, impulse momentum equation. Then I will do law of conservation of linear momentum. Then I will do projectile motion, then circular motion. Clear? So serially we will do these chapters. Now please make like, share, subscribe to all our channels. Thank you.